Yes, hi everyone. Welcome to Yourpedia platform. So friends, as you all know that Telangana Pollution Control Board and Andhra Pradesh Pollution Control Board. So the exam for Telangana Pollution Control Board is on September, and for Andhra Pradesh there is a detailed notification will be come out on this month. I think around 15th or 16th of August. So friends, one more thing that module we have already launched. And in both the exams, if we compare the syllabus, so almost syllabus is same, just difference is little bit difference about the non-technical subjects, but rest syllabus is different. Rest syllabus is same, friends. And module we have already launched about the about this syllabus. And one more point, that when notification will be come out, so after that again we are starting the module. So till then you can prepare and you can go through all the videos that you will found on the Yourpedia platform. We have uploaded many videos related to your course, so you can go through that. So today I'm going to discuss some question related to water pollution topic. So we will solve some question along with some I will explain the answers also. I will explain each and every points, so that will help you in your exams. Okay, so without wasting any time, friends, let's start the question. So question number 1 we have some statement wise question. Initially we will solve some statement type question, like statement 1 is true, statement 2 is true, both statement true, both statement is false, like this. And after that we'll solve some assertion reasoning question, and after that we are going to solve some MCQ type question, right? So initially first question we have that fluoride concentration of approximately 1 milligram per liter in drinking water help to prevent dental cavities in children. So this statement is true or false. So we have the options, 4 options we have. That option A, both statement 1 and 2 is individually true, and statement 2 is the correct explanation of statement 1. Both statement 1 and 2 is individually true, and statement 2 is not the correct explanation of statement 1. Statement 1 is true but statement 2 is false, and statement 1 is false but statement 2 is true. So statement number 1 is saying that fluoride concentration of approximately 1 milligram per liter in drinking water is help to prevent the dental cavities in children. So this statement is true or false? So yes, this statement is true. We required fluoride up to the 1 milligram per liter, because if fluoride is present in the water, so it helps in preventing the dental cavities. It helps in preventing the dental cavities. It combines with tooth enamel and makes the tooth stronger. So basically this fluoride, we require the fluoride up to this very amount, 1 milligram per liter. But remember, we don't require fluoride beyond the 1.5 milligram per liter. So if fluoride is present greater than 1.5 milligram per liter in concentration, then it dental fluorosis problem will be there. So acceptable limit as per the IS 10500 our drinking code, according to that code, the acceptable limit for the fluoride is 1 milligram per liter, and the code for rejection limit is 1.5 milligram per liter. So this statement is true. During the formation of permanent teeth, fluoride combines chemically with tooth enamel, resulting in softer and weaker teeth that are less resistant to decay. No, during the formation of the permanent teeth, this fluoride combines chemically with tooth enamel, resulting in harder and stronger, teeth that are less resistant to decay, that are more resistant to decay, right? So that's why fluoride helping in the prevention of dental cavities. So statement 1 is true, but statement 2 is false, because it is written as softer and weaker. It makes our teeth harder and stronger. So statement 2 is false. Now question number 2 we have that virus is a living organism in a natural environment including soil, and virus comes to life after entering the host tissue through the contamination. Now this statement, virus is a living organism, basically virus is the living as well as the non-living organism, right? The basic unit of life is cell, everyone knows, but virus is the non-cellular organism. It comes into picture when it exists on a living body. But when virus exists, let us suppose, on any non-living surface, then it will act like a non-living organism. But when virus exists on a living surface, on a living body, then it will behave like a living organism. So virus is the living organism in a natural environment including soil? So no. Including soil, if you are talking about including soil, so if virus exists on a soil, so it will behave like a non-living organism, right? But if you are talking about like a plants, if you are talking about human bodies, then it will act like a living organism. So statement number 1 is false. Virus comes to life after entering the host tissue through the contamination. This statement is true because virus needs a host. If no host is there, it will act like a non-living organism. So virus comes to life after entering the host tissues through the contamination. Now we have a question number 3, friends, like the ability of the water to conduct the electricity known and measured as the specific conductance and the concentration of total dissolved solids are not relatable on one-to-one basis. Now listen, this is the point that the ability of the water to conduct electricity. If we have a water sample and through this water sample current is passing, that means the ability of the water sample to conduct the electricity. This property is known as the specific conductance of the water. This property is known as the electrical conductivity of the water. So if our water sample possesses some electrical conductivity, what does it mean? It means our water sample consists some ions, because these ions are responsible for the electricity, for the current passing. If current is passing through the water sample, so our water sample consists some amount of ions, right? So electrical conductivity comes into picture because water consists ions. If you have a pure water, no ions, let us suppose, then it will not possess any electrical conductivity. So the ability of the water to conduct the electricity known and measured as the specific conductance, and that property it is termed as the specific conductance, and the concentration of total dissolved solids are not relatable one-to-one basis. It means we know that all the ions which are present in our water sample, all the ions are the dissolved solids, and we know electrical conductivity is the function of ionic strength. More is the ionic strength of the water, more will be the electrical conductivity of the water will be found. But if all the ions are the dissolved solids, so we can say if ions are more, that means dissolved solids are more, electrical conductivity will be more. But oppositively, if we say all dissolved solids are ions, opposite, it is not correct. All the ions are dissolved solids, but all the dissolved solids are not ions. Some dissolved solids are there which are not in ionic forms. Some dissolved solids are there which will be found in ionic forms. So some dissolved solids are in ionic forms, some dissolved solids are in non-ionic forms. So remember this. So that's why we can say if dissolved solids is high, so will electrical conductivity is the high. So can we relate it one-to-one basis? No, we cannot relate on one-to-one basis because all the dissolved solids are not ions. So we cannot relate. So that are not relatable on one-to-one basis. Yes, this statement is true. This cannot be related on one-to-one basis. Many organic molecules and compounds dissolved in the water without ionizing and hence are not taken into account while measuring the specific conductance. So this statement 2 is correctly explaining the statement 1. As I told you that some substances are there which are not present in ionic forms. Like example, some organic molecules and compounds that dissolve in the water without ionizing. So that's why these are not in ionic forms, but these are the dissolved solids. So that's why you can say that they are not relatable on one-to-one basis. Statement number 1 is true and statement number 2 is also true, and statement number 2 is correctly explaining the statement number 1, right? Now friends, fourth question here, like water with heavy algal growth often has pH value as high as 9 to 10. So we have a water, and in that water, you are finding that a high amount of algal growth is there. So we know one phenomena we have, eutrophication phenomena, when excessive supply of nutrient is there into any water body. So in that water body you will find the algal growth, that is named as the eutrophication phenomena. So this is basically due to the supply of the nutrients. So primary pollutant of the lake, we know that is the phosphorus is the primary pollutant. So water with a heavy algal growth, so we are talking about the water in which high amount of algal bloom is there, algal growth is there. So water with a heavy algal growth often has a pH value as high as 9 to 10. So if we talk about the pH of that water in which eutrophication phenomena is there, in which algal growth is there, algae is there, so that water having the pH about 9 to 10, this statement is true. Yes, this statement is true. So that water having the pH is 9, right? So this statement is it is saying that pH value as 9 as 10. Yes, this statement is true. But statement number 2, non-utilization of the bicarbonate ion as a carbon source by algae can result in substantial accumulation of OH negative ions. Now this statement is false. This basically reason behind that, we are saying that water with heavy algal growth having high pH 9 to 10. What is the reason behind that? The reason behind that utilization. The reason behind that utilization of the bicarbonate ions as a carbonate source. If you write this bicarbonate ion, and in this bicarbonate ions, this is the carbon source. This is the carbon source for the microorganism. So microorganisms are consuming this carbon. So utilization of the bicarbonate ion as a carbon source by algae can result in substantial accumulation of OH negative ions. For this, let's go through this reaction. So what happens when this reaction, when we talk about this reaction, so in this reaction what happens, this bicarbonate ions, in this bicarbonate ions, this carbon is consumed by the algae. This carbon is consumed by the algae. So that's why the high OH negatives, the accumulation of OH negative is going to be take place. So when OH negative accumulation is going to be take place, so in that case pH will is going to be increased, you can say. So last reaction is the weaker reaction, but utilization of bicarbonate by algae drives the reaction to the right, and hence sufficient accumulation of OH negative takes place. Hence if algae is present, it becomes the alkaline. It becomes the alkaline. So remember these points. So here it is written as known utilization. If known word is not written, then this statement is also true, but here it is written as known. So this statement is false. So statement 1 is true and statement 2 is false. Statement 2 is false. Now question number 5, that recarbonation of water softened by lime soda process results in increased hardness of water. Now we know the point that when we talk about the lime soda process, in this lime soda process, this is the basically a softening method to remove, for the removal of the hardness. So when we add the lime, so lime is going to remove some type of hardness, and when we add the soda ash, it is also going to remove some type of hardness. So if we take what actually lime removes, so all the carbonate hardness will be removed by the lime alone. So when you add lime in your water sample, all the carbonate hardness will be removed. Secondly, this lime convert the magnesium non-carbonate hardness into the calcium non-carbonate hardness. That means the non-carbonate hardness of calcium is not removed by the lime. So this magnesium non-carbonate hardness, that means non-carbonate hardness due to the magnesium, is converting into the calcium non-carbonate hardness by the help of lime. Third point, lime reacts with CO2 that is present in the water, and it reacts with CO2 and forming the precipitate of CaCO3. Now when we say these, in the water sample, all the carbonate hardness is removed and all the magnesium non-carbonate hardness is converted into the calcium non-carbonate hardness. So this calcium non-carbonate hardness is further removed by the soda ash. Sodium carbonate, we add soda ash in our water sample. So lime and soda combinedly, they are removing this hardness from the water sample. So when we talk about lime and soda, and when we talk about the removal of hardness, so basically this hardness being removed in the form of precipitates. So in this process, precipitates are going to be formed, that calcium carbonate, magnesium hydroxide. Calcium carbonate and magnesium hydroxide precipitates are going to be formed. Some precipitates forms earlier, but some precipitates forms very slowly. They will take more and more time, right? So that's why this too much time if they are taking. So when we supply the water into our distribution system, and in the distribution system, those precipitates which are taking the time, they will form in the distribution systems, and when these precipitates forms in the distribution system, they are getting deposited on the pipes. That means incrustation problem will be there, that further reducing the discharge carrying capacity. So that's why what we do, we again made, so in what we do, we don't allow them to form the precipitates. Basically what we are doing, we again made them in soluble form. We made in them in soluble form by passing the CO2 in water sample. So some amount of hardness is not removed during the lime soda process. That hardness again being made soluble in our water by passing the CO2, and this process is named as the recarbonation process. So recarbonation of the water softened by lime soda process results in increased hardness of the water. Yes, because during the recarbonation, what we are doing, we are again the precipitates again these precipitates again being made soluble in the water. So that means again multivalent cations will be present in the water sample. That is going to increase the hardness of the water sample. So up to 50 milligram per liter of hardness HCaC3 is not removed, in which 40 milligram per liter of calcium carbonate precipitate and 10 milligram per liter of magnesium hydroxide precipitates, we don't allow them to remove. This is again being made soluble in the water by passing the CO2. Suspended solids like calcium sulfate, magnesium sulfate, which have not settled in the sedimentation tank, get dissolved due to the passing of CO2. No, we are not talking about these precipitates. We are talking about the calcium carbonate and magnesium hydroxide precipitates. We are talking about these precipitates, magnesium hydroxide precipitates and calcium carbonate precipitates. So statement number 1 is true, but the statement number 2 is false, right? Question number 6 we have, friends, dilution of the wastewater sample with organic free oxygen saturated water is necessary to measure 5-day 20 degrees Celsius BOD values greater than 7 milligram per liter, and the saturation concentration of oxygen in the water at 20 degrees Celsius is approximately 9 milligram per liter. Now question is saying that we have a dilution of the wastewater sample with organic free oxygen saturated water is necessary to measure 5-day 20 degree Celsius BOD values greater than 7 milligram per liter. That means if you perform the test for the BOD, and if you want BOD of your wastewater sample more than 7 milligram per liter, so you have to make dilution. You have to do dilution. If you don't make it, if you don't dilute your water sample, in that case BOD comes out to be less than 7 milligram per liter. If you want that BOD of the water sample should be more than 7 milligram per liter, you have to dilute your water sample. Why? Because this as per the Henry's law, solubility of the any gas is inversely proportional to temperature. If temperature increases, solubility of the gases decreases. If temperature decreases, solubility of gases increases. So at 20 degrees Celsius, the maximum concentration of the dissolved oxygen that can be found in the water sample is 9.12 to 9.2 milligram per liter. Suppose that, let's take an example, we have a water and that consists 9 milligram per liter. And when we perform the BOD test, so we have some conditions that during the test, the consumption of oxygen should be at least 2 milligram per liter. Final oxygen should be left in the water sample must be 1 milligram per liter. So some conditions are there. So by using those conditions, so if we found the our answer, so we can determine the BOD. Suppose that we have a test sample, we have a wastewater sample, and we know in our wastewater sample initially DO is very less. We know that point because the wastewater sample consists DO very less, because the organic matter which are present in the wastewater sample, they are under decomposed by the action of microorganism. So in the decomposition of organic matter, consumption of oxygen will be there, so that original wastewater sample will consist very lesser amount of oxygen. And we are performing the test for at 20 degrees Celsius. So that means again you will found that's lesser amount of DO, and during the 5 days depletion of oxygen will be there. So you will found that initially as our test sample consists DO is very lesser amount. So when we perform the test, again we have a final DO that will be very lesser value. So we have to dilute the sample. The saturated concentration of oxygen in water at 20 degrees Celsius is approximately 9 milligram per liter. So if we consider that BOD of our wastewater sample, let us suppose, or you can say DO of the test water sample is 9 milligram per liter, because at the 20 degrees Celsius maximum DO is 9 milligram per liter, 9.12 to 9.2, this is the range, just we are assuming it is 9 milligram per liter. Because this range is very less, this value is very less, so by using the test conditions that I told you, if you apply those test conditions, in that case if you find and if you want answer of BOD above than 7 milligram per liter, in that case the DO of the test sample should be higher than the 9 milligram per liter. So that's why it becomes necessary to dilute the water sample. So just remember this point. So the saturation concentration of oxygen in water at 20 degrees Celsius is approximately 9 milligram per liter. Right. So just correct it. Statement 1 is true and statement B is also true, and statement 2 is correctly explaining the statement 1. So here both the statements are true and statement 2 is correctly explaining. So I think some some typing mistake is there. So just write down this answer is A, right? So okay friends, now moving on, next question we have question number 7. Tapered flocculation is more efficient when compared to the conventional process of flocculation. Tapered flocculation is more efficient when compared to the conventional process of flocculation. Now what is the meaning of tapered flocculation? Basically what happens, so this we have a flocculation tank, and in this flocculation tank we are using the slow mixing process concept. So here the shaft we have used, so we have supplied the power. So the shaft which are you can say which are kept at the entry position, at the entry point. So here the power or the G value we are keeping it higher, or the power supply to the shaft or at the entry, the shaft which are present at the entry, the power supply to them is higher. But as we move along the length of the tank, so the power supplied by us to the shaft is reducing. So lesser power is required and higher power is required at the entry point. So G inlet is greater than G outlet. So this type of flocculation is named as the tapered flocculations. This type of flocculation is named as the tapered flocculations, right? So why we do this? Because we know the concept that when water will enter from here, so initially the time required by the particles for their agglomeration is less. So at the earlier section, when G value is higher, and we know when G value is higher, friends, what happens when G value is higher, when G and time required for their particle for their agglomeration is less at the initial section. So which type of flux formed? So when G value is higher, X is less, and X is less, so dense flux will be formed, but T is less, so small flux will be formed. So you will find that small and dense, you will find that small and dense flux formation, small and dense flux formation, small and dense flux formation, right? Small and dense flux formation. But as the water moves throughout the length of the tank towards the outer section, so at the exit point you are supplying the more power. So here you are supplying the lesser power. At the entry G value is higher, but at the exit G value is lesser. So here G is less, so the time required by the particle for their agglomeration is high, time of contact is more. So as you move along the length of the tank, G value is reducing, but T value is increasing. So here you will find light and larger flux, So both type of flux are going to be formed in our flocculation tank. So in that way we have higher efficiency, we got higher efficiency. So this is named as a tapered flocculation because the power is reducing along the length of the tank that we have supplied to the shaft. In tapered flocculation, the velocity gradient at the inlet is less than that at the outlet. No, it is written opposite, it is written wrong. In tapered flocculation, the velocity gradient, that is the G velocity gradient, this at the inlet we keep higher, but at the outlet we keep lower, right? Because G we have a formula, temporal mean velocity gradient √ P by mu v. This is the G, temporal mean velocity gradient, friends. This is the G value. So this statement is true, but this statement is false. Question number 8. Ozone is not widely used in community water supplies. Yes, ozone is generally not used. Generally, ozone is not used. Reason being, because the contact time, or you can say the residual concentration, because it has highly reactivity. It has highly reactivity, but it does not safeguard the water against the future recontamination. If our water becomes, let us suppose, when we supply the water to the distribution means, and if it recontaminate, so this some amount of chemical should be in the water, so that safeguard the water against that future recontamination. So if that ozone, although it is highly reactive, but it is unstable compound. It does not remain in the water for a longer duration. It is unstable compound. So that's why, because it is not possible to maintain residual concentration of ozone in the water after the disinfection process. So that's why ozone is not widely used. If you are using the ozone, so you have to consume the water as soon as possible. If you takes too much time, so the recontamination chances may be increased. So there will be no ozone, there will be no residual ozone in the water sample, so that safeguard the water. So just remember this point. So that assertion is true, reasoning is true, and friends, reasoning is correctly explaining the assertion. Question number 9. In the case of the dual media filter, the rate of filtration is more than the rate of rapid send filter. Now what happens here, basically what happens, what is the meaning of dual media filter, or you can say roughening filter? We want to increase the rate of filtration of slow sand filter. So we know the slow sand filter and we want to increase its rate of filtration. But what happens if we increase its rate of filtration? Efficiency get reduced. We get the reduced efficiency, we get lesser efficiency. So without compromising any efficiency, we want same efficiency which we want same efficiency, and we want to increase the rate of filtration. We want to increase the rate of filtration of slow sand filter, but we don't want to get any we want same efficiency. So in that case, what we do, before slow sand filter we take rapid sand filter. We use rapid sand filter before the slow sand filter. So first water will flow through the rapid sand filter, after that water will flow through the slow sand filter. By doing this stage, we get the desired efficiency which we want, and also we have increased their individual rate of filtration. So this is named as the dual filtration, or the rapid sand filter which is used earlier than the slow sand filter. This rapid sand filter is named as the roughening filter. Sometimes question asks, what is the roughening filter? So this rapid sand filter is named as the roughening filter. So the question mark is saying, question is there that why we are using this roughening filter, why we are using this dual media filter? To increase the rate of filtration. Our aim to increase the rate of filtration, but if we increase the rate of filtration, efficiency will be reduced. So without compromising the efficiency, we want to increase the rate of filtration of slow sand filter. So in that case, we have to use rapid sand filter before the slow sand filter. In that case, we get the same amount of efficiency, but individually we have increased their rate of filtration. So in the case of dual media filter, the rate of filtration is more than the rapid sand filter, than that of rapid sand filter. Yes, here the rate of filtration is more. This statement is true. The direction of flow is from fine medium to coarser medium. The direction of flow is from fine medium to coarser medium. No, the direction of flow is not from fine medium to coarser medium. This statement is wrong. So the dual media filter has anthracite coal, or you can say silica sand as a medium. So here this medium we are using. So this statement is, this reason is wrong, but assertion is true. If direction of flow is taken from fine medium to coarser medium, then you will say the rate of filtration will be lesser. Rate of filtration will be lower, right? Because we have increased the rate of filtration. So obviously that you will say that's throughout the filter media there is the uniformly material present, or you can say coarser material is present. If fine particle is present, so rate of filtration comes out to be lower. Chloride should be absent in the drinking water. Chloride should be absent in drinking water. Chloride gives salty taste to the water. Chloride gives salty taste. As chloride gives salty taste to the water, so some amount of chloride should be present in the water sample. So chloride should be absent? No. The acceptable limit for the chloride is 250 mg per liter, and the cause for rejection limit is 1000 mg per liter. Cause for rejection limit is 1000 mg per liter. Cause for rejection limit is 1000 mg per liter, we know. So some amount of chloride should be present. So assertion is wrong, but reasoning is true. As chloride gives salty taste to the water, so some amount of chloride should be present in the water sample. But remember one more point, excess chloride water is named as the brackish water. If we say brackish water, the water which consists chloride in excess amount. Breakpoint chlorination is required to ensure free chlorine residual for better disinfection. Free chlorine residual have a good disinfecting power, and they are usually dissipated quickly in the distribution system. So yes, we know that free chlorine residual like HOCl, and we have a combined form of chlorine, that is the chloramines, dichloramine, NHCl2. So we have dichloramine combined form, combined residual, free residual, HOCl, and we know among these compounds, free form of chlorine has high reactivity. They are 25 times more reactive than the combined form. So their reactivity is high, but their stability is lesser. So to safeguard the water against the future contamination, so we ensure the residual chlorine, but this residual chlorine is in form of chloramine, is in the form of chloramine. So that's free chlorine residual have good disinfecting power. Yes, it has good disinfecting power, and they are usually dissipated quickly. Yes, because they have high reactivity, they are unstable, they cannot remains in the water system for the longer duration, they cannot remains in the water system. So yes, they are usually dissipated quickly in the distribution system. So this statement is true, this reasoning is true. Breakpoint chlorination is required to ensure free chlorine residual for better disinfection. Yes, breakpoint chlorination, we perform the test for the chlorination, and breakpoint chlorination is required to ensure free chlorine residual. Free chlorine, generally we keep the free chlorine residual as 0.2 milligram per liter at a contact period of 10 minutes, at a contact time of 10 minutes. So this breakpoint chlorination is required to ensure free chlorine residual for better disinfection. So that means when we talk about this assertion is true, and free chlorine residual have good disinfecting power, and they are usually dissipated quickly in the distribution system. So this reasoning is also true. So I think some error is there answer. So it should be B option. It should be B option, right? It should be B option. So just correct it. Now question number 12. In the secondary sedimentation tank of sewage treatment plant, the settling particles from a blanket which descends and capture the more particles. The particles are flocculent and are in very high concentration where there is an efficient working activity sludge or trickling filter process. Now assertion and reasoning, you have to tell that which answer is assertion is true, reasoning is true, correctly explaining. So here when we talk about the secondary sedimentation tank, and in the activated sludge process case we have sludge blanket phenomena. So question is saying, assertion is saying, in the secondary sedimentation tank of sewage treatment plant, the settling particles from a blanket which descends and captures more particles. So which forms a blanket, the settling particles forms a blanket which descends and capture more and more amount of particle, and the particles are flocculent and in very high concentration whenever there is an efficient working activity sludge or trickling filter process. So both statements are correct, right? The sludge processing utilize the aerobic digestion in which it's converted to CO2 and methane. The sludge processing utilizes the aerobic digestion. Now we know when end product of anaerobic digestion is acid alcohol gases, end product of aerobic digestion is carbonate, sulfate, nitrate, like this. So sludge processing utilize the aerobic digestion in which it is converted to CO2 and methane. So this statement is wrong. The acid forming bacteria convert the complex organic such as fat, protein, carbohydrates into organic fatty acids. The methane forming bacteria convert organic acid to CO2 and CH4. This statement is true. We know the methane formers, acid formers. So acid formers generally convert organic matter into the acid alcohol and along with some CO2, and this acid alcohol and CO2 further converted into CH4 by the methane formers. So this reasoning is true, friends. This reasoning is true. Question number 14. Chlorophyll bearing plants take water and carbon dioxide to synthesize the carbohydrates. They make their own foods, they are autotrophs. So chlorophyll bearing plants take water and carbon dioxide to synthesis. We know that autotrophs generally utilize inorganic carbon, and the inorganic carbon is found in the carbon dioxide. So the chlorophyll bearing plants take water and carbon dioxide to synthesize the carbohydrates. Yes, it is true. Wasted food ultimately leads to production of various natural resources like water and sunlight energy. This statement is absolutely wrong. So electrical conductivity of water and total dissolved solids are interrelated. The value of electrical conductivity will, as we know that electrical conductivity increases with increase in TDS. So but this is not related one-to-one basis. We know this point. As more is the TDS, more will be the electrical conductivity, but they are not interrelated with the one-to-one basis. As one more point, as the temperature of water increases, also electrical conductivity increases. Remember this point also. right? For exam point of view, when temperature increases, also electrical conductivity increases. So we have to match list 1 and list 2 parameters and their permissible concentration is given, friends. Hardness, so we know the hardness permissible limit is 200 milligram per liter as CaCO3, and nitrate concentration 45 milligram per liter. If nitrate is more than 45, then it will cause the methemoglobinemia, blue baby syndrome. Iron concentration, fluoride concentration, and we know the fluoride concentration up to 1 milligram per liter it is being required by us. So as per the options, so we go for 0.5 because it is higher value. So iron concentration we go for this 0.1 milligram per liter. So you can match the answers like this. Right? For iron, permissible limit is 0.3 milligram per liter, but in the option it is given 0.1, so we go for this one. And the for fluoride is 1.5 milligram per liter, but in the option 0.5 is given, so we are taking that values according to the options. Now again you have to match list 1 and list 2. So we know when absence of fluoride is there, because we require the fluoride up to 1 milligram per liter. If fluoride is not there, then dental cavities will be there, so it will relate with the dental cavities. Excess of lead, when lead is present in excess, then it will cause some anemia problem. Presence of excess nitrate, then it will cause the methemoglobinemia situation. And absence of iodide, it will cause the goiter, some swelling in the you can say neck, near the neck region. So that is the goiter problem, right? Absence of iodide, that is due to the absence of iodide. Which of the following is the characteristics of the coliform organisms? Coliform organisms are the basically microorganisms, are the non-harmful microorganisms, and they becomes the indicator for the pathogens. We test the water for the presence of the coliforms, and further by using some calibration technique we found the pathogens that present in the water that are related with the pathogens that are related with the coliforms which are present in the water sample. So we test the water sample for the coliforms and we found the pathogens by some calibration technique, right? Nowadays we are performing the MFT technique test, membrane filter technique test. We perform this test that takes 24 hours time, and that require different medium depending what is our aim to find. If our aim is to find the total coliform, so we have a different medium that we use the M-endo medium. But if we want to confirm, if we want to find the fecal coliforms, so we are using the different medium, generally MFC agar we are using in that case. So different medium we have, right? Membrane filter technique. But when we talk about the coliforms, so they possess some characteristics. Like coliforms are the microorganisms which are bacillus in shape. Bacillus in shape means they are the rod-shaped bacteria. They are the rod-shaped microorganism like this. So they are the rod-shaped microorganisms. So these are the bacillus. These are the gram-negative. So they are the gram. Just remember all the key points related to the coliforms. Coliforms are the bacillus in shape. They are the gram-negative, not gram-positive. They are the gram-negative. And when we do basically staining technique test, so in the staining technique test, some microorganism will produce a red stain, some blue stain. So accordingly we are saying that. So just you have to remember the key points related to the coliforms, that coliforms are the bacillus in shape, gram negative. They ferment the lactose, they ferment the lactose, and when microorganism or when coliforms ferment the lactose, they will produce gases. They are producing the gases, and that gas we trap in a Durham tube. We have a Durham tube. In Durham tube that gas is being trapped. So they ferment the lactose. They are the non-spore forming, not spore forming, they are the non-spore forming. This is the basically a state in which microorganism you can say with respect to time they become like acid resistant, water resistant. So that is the non-spore forming. So they are the non-spore forming, not spore forming. So only statement 1, 2 and 3 is correct. If methyl orange alkalinity of water equal or exceeds the total hardness, then all of the hardnesses. So we know one concept we have, that we have a alkalinity and we have a total hardness. So among this, whatever the value which is minimum, so that value is equal to carbonate hardness. So suppose that among alkalinity and total hardness, question is saying if methyl orange alkalinity greater than or equal the total hardness, that means among these minimum value is total hardness. So all of the hardness, all of the total hardness will be carbonate hardness. So carbonate hardness will be equal to total hardness, because among these two values, whichever is minimum value, that will be carbonate hardness. So non-carbonate hardness if we want to find, then we have to subtract total hardness minus carbonate hardness. So total hardness equal to carbonate hardness, answer is 0. That means all of the hardness will be carbonate hardness. So carbonate hardness will be equal to total hardness. That means non-carbonate hardness will be 0. Non-carbonate hardness will be 0. The amount of bleaching powder containing 20% available chlorine needed to chlorinate a rural water supply covering a population of 10,000 at 50 LPCD at the rate of 2 ppm is. Now the friend question is this, what is the amount of bleaching powder? We have to find the dose of the bleaching powder, and the question is saying that this bleaching powder consists 20% available chlorine. This 20% available chlorine means its percentage purity. So this is given, that means it is mentioned the percentage purity of the bleaching powder. Remember this point? Percentage purity of bleaching powder is mentioned here. It is the 20%, and this available chlorine and needed to chlorinate a rural water supply covering a population. So we are supplying the water into a community that having a population of 10,000, and the water demand per capita is 50 liter. So that means on an average 50 liter water is being required by a single person. So total water would be required by a community that we have to multiply with population 10,000. So total amount of water we have 50 multiplied 10 raised to power 4. This amount of water we have to treat. For the treatment of this water, the amount of bleaching powder required, and generally it is given as the rate of 2 ppm. That means 2 milligram per liter. So 1 liter water required 2 milligram chlorine. 1 liter water required 2 milligram chlorine. So this amount of water required, so just we have to multiply 2 milligram. But given options are in kg, so we have to multiply with 10 ki power minus 6 to convert in kg. So this answer will be in kg. But remember, we are adding the bleaching powder, right? This is the requirement of the chlorine, but we are adding the bleaching powder, and bleaching powder is not 100% pure. Bleaching powder, the percentage purity is given 20%. That means if we add this amount of bleaching powder, only 20% of this value will be worked out, right? So we have, because this amount of bleaching powder required, this amount of chlorine is required, so we have to add more amount of bleaching powder, so that 20% of that amount will be comes out to be equal to this value. So that's why we have to divide this value by 0.2, 20%. So by doing this we get the answers. So if you do this, then you have an answer of 5 kg. You have an answer of 5 kg, right? Now, which of the following statements are correct? Groundwater is generally free from suspended and dissolved impurities. No, groundwater is generally free from suspended solids. River water generally consists high amount of suspended solids, but if we derive the water from the ground, so we know that water coming from the voids of the soil, so no suspended solids will be there. But as groundwater having deficiency of oxygen, so aeration treatment is not being there. So that's why groundwater, as in contact with longer duration, it is contact with soil, minerals, so it will consist larger amount of dissolved solids. So remember this point, groundwater consists dissolved impurities in high amount, but it will consist suspended solids in very lesser amount. So remember this point. So in dissolved impurities, first statement is false. Suspended matter often contains pathogenic bacteria. Yes, in our water sample, if suspended solids are present, so some of these solids may be biodegradable in nature, and if these solids are biodegradable in nature, so due to that microorganism may grow, and these microorganisms may be pathogens. So yes, some suspended matter often contains pathogenic bacteria. This statement is true. Rainwater is soft and tasteless. Lake water may contain microscopic organisms. Yes, lake water may contain microscopic organisms. Lake water may contains microscopic organisms, right? Because it is the stagnant water. Every stagnant water, it is not the moving water, no? It is stagnant water. It will consist maybe some of the microorganisms. So second and fourth statement is correct. Second and fourth, along with the third statement, rainwater is soft and tasteless. Generally rainwater is soft and tasteless. Why we are saying soft? Because it doesn't consist multivalent cation in higher amount, so that's why we are saying it is the soft. Now question number 22, you have to match dissolved sulfates of and chlorides of calcium magnesium. So we know due to this calcium magnesium, when combined with sulfate, chloride and nitrate, they will produce the non-carbonate hardness, permanent hardness. So hardness and corrosion will be there, and alkalinity, impairment, dental bacteria. So the answer of this one, dissolved bicarbonate of calcium magnesium. Also we know when calcium magnesium combines with carbonate and bicarbonate, they will produce the carbonate hardness. But here in the options carbonate hardness is not given, but it is mentioned bicarbonate. So when calcium bicarbonate or magnesium bicarbonate is there, no doubt carbonate hardness will be there, but as well as alkalinity will also be there. So that's why we can go for the alkalinity. Bicarbonate alkalinity will be there. Dissolved fluoride of sodium, that means sodium fluoride, so that will go into impairment of dental health. Fluoride is related with the dental health. Dissolved organic matter, that is related to the bacterial infection, that you can relate with the bacterial infection. I hope it is clear, friends, right? Which of the following treatment reduces the salinity of the water? So our water sample consists salts in high amount and we want to remove the salinity, we want to reduce the salinity of the water sample. What we can do? Can we go for the flash mixing or sedimentation? No. By flash mixing or sedimentation, salinity cannot be removed, dissolved solids cannot be removed. And electrodialysis, yes, we can go for the electrodialysis. Reverse osmosis, we can go for the reverse osmosis. Freezing, we can go. Filtration, by the filtration we can remove, no doubt, by the filtration we can remove also, but according to the options there is not mentioned in the option 2, 3, 4 and 5. Filtration is also removing the dissolved solids, but remember question is saying that we have to reduce the salinity of the water. If particularly question asked about the salinity, so in that case filtration we can avoid. But if in the option it is given, if in the option it is given filtration 2, 3, 4, 5, then we will adopt the filtration, because we have a nano filtration technique also, ultra filtration technique. So in this filtration technique we can remove the salinity, we can remove the salinity. So all these points are can be used, all these points can be used for the removal of salts. So remember this point, right? The cleaning of slow sand filter is done by, generally slow sand filter, because we know that slow sand filter there is a cleaning, that is surface cleaning we generally prefer. Surface cleaning, because all the impurities will be removed, all the impurities removed at the surface, all the impurities will be retained at the surface only. So from the surface we remove the impurities. So cleaning of slow sand filter is done by scraping of top layer of sand and admitting the water, that means surface cleaning, generally it is termed as the surface cleaning. But if in the case of rapid sand filter, we have to use the back washing concept also along with the surface cleaning, we have to use the back washing concept also. So again we have a match, we have to match the name of the impurities and which that impurities can be removed by. So fluoride, manganese and taste and odor. So if we talk about the fluoride, we have activated alumina. Activated alumina is also named as the Prashanti method. We have a Nalgonda technique for the removal of fluoride, that we can say alum plus lime we use in the Nalgonda technique. Manganese, for removal of manganese we use the manganese zeolite, as the name suggests, manganese zeolite is used for the removal of manganese. Taste and odor, that is generally due to the dissolved impurities and that are removed by the activated carbon, right? Adsorption phenomena generally be there. So again you have to match some points, that hardness. For hardness we go for EDTA method, in which ethylene diamine tetraacetic acid indicator we use, titrant we use, and EBT, Erichrome black tea indicator we use here. In the chlorine case we go for orthotolidine test. Generally in orthotolidine test residual chlorine we found, we find from the water sample residual chlorine. But nowadays we don't perform this orthotolidine test, we do go for the DPD test, or chlorotex test. These are the BDH, British Drug House reagent. So we generally use this test. DO is found by the modified Winkler's method. This is only Winkler's, but we use modified Winkler's method. Chloride is by Mohr's method by chloride, right? Protozoa, bacteria, and again you have to match some waterborne disease, like due to the nitrate, if nitrate is present more than 45 mg per liter concentration, then due to this methemoglobinemia problem will be there. And due to the protozoa and virus, poliomyelitis will be there, and due to the bacteria typhoid fever is there, or generally if I talk about typhoid fever, Salmonella typhi is the bacteria, name of the bacteria, Salmonella typhi. That due to that typhoid fever will be there, typhoid fever is there. And due to the protozoa, dysentery will be there, but not all the dysentery is due to the protozoa, like amoebic dysentery is due to the protozoa. And if question asks about the sedulous dysentery, that is due to the bacteria, right? So just remember the name, very important. These are important points. So we have discussed everything in the class, Which of the following organism is responsible for the enteric fever threats? Which one of the following organism is responsible for the enteric fever? So if question asked about the enteric fever, so the answer is Salmonella typhi, and due to the Salmonella typhi, the typhoid fever is there. Salmonella typhi and Salmonella paratyphi bacteria causes enteric fever. Just remember the name. As per the exam, just remember the name. Now we have some water parameters and their test, like chloride, residual chlorine we know, orthotoletin test, hardness of water, EDTA method, potability of the water, that means the potable water which is fit for drinking, that means the water should not consist any type of microorganism. For the microorganism we are going to test for the coliforms, that membrane filter technique test. Chloride we have a Mohr's method. For the chloride we have a Mohr method. The following three stages are known to occur in the biological action involved in the process of sludge digestion. So the correct sequence. So here first we know that when we talk about the digestion in the anaerobic sludge digester, the PST, primary sedimentation tank in the wastewater treatment plant, the primary sedimentation tank is designed to carry out the settlement of the organic suspended solids, and these organic suspended solids when settled they are going to form the organic sludge. Organic sludge will be there. This organic sludge is sent to the sludge digester, and there anaerobically this sludge being digested, the decomposition of this sludge is there anaerobically. So this digestion is done in 4 stages. The 4 stages named as, the first we have hydrolysis, second we have acidogenesis, third we have acetogenesis, and last one we have methanogenesis. So here first point, this hydrolysis is not in mention, so that's why we can go directly in the stage number 2. So here first acid fermentation will be there, after that acid regression, and after that in the last alkaline fermentation will be there. So according to the options, answer number 3. So this is the sequence. We have 2 type of microorganism, acid formers, methane formers, like, and we know that methane formers works in the narrow pH range of 6.5 to 7.5. So friends, these all are the questions that we discussed, right? So these all are the questions that we have also these all points we have discussed in our classes, right? So friends, if you are new, then I want to share the information that module related to your course already been launched. So if you want to join, you can discuss with us. And otherwise, one more information is that when for Andhra Pradesh notification will be come out after 15th August, I think. So again we are starting the new module for you all friends, for Andhra Pradesh candidates. For Telangana, this I think exam is next of month, in the September month I think there is an exam. So we have already completed the module, and the syllabus is almost same. Just little bit difference is on your non-technical syllabus. Otherwise all things mostly 80 to 90% is same. And friends, if you want to want any classes, if you want any videos, so just go through this YouTube platform. You will find some videos related to your course. And also if you have any query related to our module, so you can discuss with us, you can contact in the institutes. Okay friends, if you have any query related to anything related to your course, related to your exam course basically, or our module, so you can discuss with us. Okay, thank you.